So let's go through the answers to our practice problems for vertical motion. Remember, vertical motion is very similar to what we did with horizontal motion. We're going to use all the same equations. We're going to use the same steps. We're going to write our givens, our letter equation, plug in our numbers, and then solve. Remember, that tells you to write all your steps, but you need to write all your steps to get full credit. So we go with our givens. A stone is dropped from the top of a cliff. It hits the ground below at 3.25 seconds. How high is the cliff? Okay, so it looks like I only have one given, but remember with vertical motion, there are some things that I can assume. When something is dropped, I can assume that it's dropped with an initial velocity of 0, and I can assume that its acceleration is always negative 9.8 meters per second squared, because that's the acceleration vertically caused by gravity. And then it tells me the time is 3.25 seconds. I want to know how high the cliff is, so I'm looking for x. I don't have a v, so that tells me that I'm going to use x equals 1/2 at squared plus v0t. Some of you are still saying, oh, I'm missing v. Okay, I'm solving for x. I want to choose the equation without the x. I can't choose an equation that doesn't have what I'm looking for. So we want to look at, to choose the equation, we want to look at what it's not given and not asked for. So we're going to choose the x equals 1/2 at squared plus v0t. Go ahead and plug in my numbers. And I get negative 51.8 meters. So that means the displacement, or the distance the stone traveled down, is 51.8 meters. So the cliff is 51.8 meters high. Car rolls gently, 0 meters per second initial velocity off a vertical cliff. How long does it take to reach 85 meters per second? So it tells me V0 is 0 meters per second. So as if we're dropping the car. We know our acceleration is negative 9.8. Our final velocity is going to be 85 meters per second. We know that's the velocity because it's meters per second. Okay. And we want to know how long, so we know we're looking for time. We don't ask for or have an x, so we're going to use our v equals at plus v0 equation, plug in our numbers, and we get 8.7 seconds. Alright, so we got King Kong falling straight down from the top of the Empire State Building, 380 meters high. How long did it take King Kong to fall? So we have the 380 meters. It's going to be negative because he's falling. He's going down. 380 meters. And then we have an acceleration of negative 9.8. We don't need time because we want to know how long. So again, we don't have a final velocity. We don't ask for it. We use our x equals 1/2 at squared plus v0t. Plug in our numbers. 77.55 equals our t squared. Don't forget to take your square root. And you get a time of 8.8 seconds. What was his velocity just before landing? Okay, so now we know our v0 is still 0. Our acceleration is negative 9.8 meters per second squared. Those don't change. Our x is negative 380 meters. I want to know my final velocity. This time I don't have time. Okay, don't use what you solve for if you can help it. I'm going to use v squared equals 2ax plus v0 squared. Plug in my numbers. My v squared equals 7,448. Take my square root, and I get a final velocity of 86.3 meters per second. Okay. And that, because we know he's falling, we know that that's going to be negative. We have to know that because we're taking a square root here. So that means we're going to have a positive and a negative answer. But this velocity here, it should actually be negative 86.3 meters per second, where he's going 86.3 meters per second down. A baseball is hit straight up in the air with a speed of 22 meters per second. How high does it go? So again, my acceleration doesn't change. Now I'm going up. So now my initial velocity is 22, and my final velocity is going to be 0. I'm going up to the top because I want to know how high it goes. I want to know where it is when it's all the way at the top. So that means my final velocity is 0 at the top because it pauses briefly. So that tells me I'm going to Pick this equation, v squared equals 2ax plus v0 squared. Plug in my numbers. I get 98.77 meters. That's my x. How long does it take to return to its starting point? Okay, so again, I have the same givens. If I'm only looking at half the flight though, so I'm going to find the time here up to my maximum height, which is 2.24 seconds. Takes the same time to come back down. So that means I'm going to have 4.48 seconds for my total flight time. This is going to be my answer here. Again, I chose this equation because I didn't have an x. V equals at plus v0. And we got another ball player. Catches at the same height about 3 seconds after throwing it upward. So that means that's the time for up and down. So the time I want for halfway to do my solving is going to be half of that, so 1.5 seconds. Acceleration is negative 9.8 meters per second squared. My final velocity at the top is going to be 0. So I'm going to find my initial velocity, and so then I choose my v equals at plus v0 equation again, plug in my numbers, and I get 14.7 meters per second is my initial velocity. And remember, I use half the time because it says he caught it back at the same height at 3 seconds. So that means to get to the top, where the final velocity is 0, it was only 1.5 seconds. And then what maximum height that was, and 1.5 seconds later, initial velocity of 14.7, final velocity of 0. This one we have to use what we solved for because there is no equation without it with 0. I picked the one with the easiest math. I could have used any one that I wanted that has an x in it, but I get an x of 11 meters. And then an object starts from rest and falls under the influence of gravity. Draw the velocity graph and the displacement graph at 0 to 5 seconds. So my v versus t graph is going to be speeding up backwards. It is falling. Down is the negative direction. And then I have my speeding up backwards position time graph. My slope gets progressively steeper. It's backwards. So it has an overall negative slope.